Right friends, now let's see how to work with this problem. It says y is equal to x power n. Let us see how to differentiate y is equal to x power n using first principles and how to use this formula while differentiating algebraic expressions. Right, let's go ahead. As we know, the first stage of the problem is what? To increase x as what? X plus delta x and y to y plus delta y. So there is a small increment in both these guys. Right, so let me substitute these guys here. Or get y plus delta y is equal to x plus delta x to the whole power n. Alright, so a lot of tricks in this and a couple of manipulations where we'll do a small cheating also to remember a couple of formulas which we don't know from first PU. Alright, anyway, let's continue. What does the first stage say? We need to keep delta y on one side and rest of the things on the other side. So I have delta y here, and that goes like x plus delta x to the power n minus y. So can I write y as back? My question is x power n, x plus delta x to the whole power n minus x power n. Okay, fine, this is what I have. Right, the next stage is to divide both the sides by delta x. Let's go ahead with that. Second stage is what we have, and I can divide delta y by delta x on left hand side, and I'll take x plus delta x to the whole power n minus x power n, the whole thing divided by delta x. Now that's my second stage. Now the question is, can I cancel delta x in the denominator? No, I can't, because I cannot cancel this guy with this. Now we are stuck. Right, now we need to go to a formula from first PU which says limit of z tends to x. I can write z to the power n minus x to the power n by z minus x. This whole thing is given as n into x power n minus 1. Okay, that's the formula. The whole talent now to do this problem is to convert what I have to that form. Correct? Now see, if I see that formula, I have z to the power n, x to the power n. So x power n is there, but there is no z here. And denominator is also the same, z minus x, but there's only delta x here. How can I make this guy look like this whole denominator? Can I add plus x and minus x? Yes, now this guy looks like this, and this guy looks like this. Alright, and still this would not be looking like that because I have two terms here and a single term there. Can I take z is equal to x plus delta x in this equation? See what happens now? Very simple. Delta y by delta x, that will look like z power n minus x power n. Yes, and z minus x. Very simple. Right, now when I apply limits, let's say limit of delta x tends to 0, delta y by delta x is what I have. That goes like limit of delta x tends to 0, then it goes like what? That is z to the power n minus x power n, or z minus x. Yes, exactly. But can I apply the same limits, or can I change the limit also? See here, we need to change the limit because here the limit is z tends to x, and here the limit is delta x tends to 0. But I can't use the formula if not z tends to x. So how can I solve this? I can say that if in this equation, what I took the substitution here, alright, if z is equal to x plus delta x. Now look at this, if delta x is becoming 0, let's say it's becoming 0, then what's happening to z? That is becoming x. See, right? Look at this. Yes. So I can write if delta x becoming 0, z is becoming x. Right? So I can use that limit here on the right hand side. So what happens here? You can write limit of delta x tends to 0 into delta y by delta x is limit of z tends to x, and I have z power n minus x power n by z minus x. That's all it is. Right? According to this formula, what do you get? The right hand side. The left hand side is dy by dx, and the right hand side is, I see that n into x power n minus 1. Okay, that's the simple formula we have. Right, let's do a couple of more problems on this formula and how to use this guy in your differentiation. Right?